Well, good afternoon, everybody. Thank you for joining this web seminar. I am Arco de Vos. I've been working for AOPEN for roughly 10 years now. The last couple of years I've been managing the FAE department. I don't mean to brag or anything, but the FAE department could be one of the founding pillars of AOPEN. We can help you get solutions or answers to technical challenges or questions. We can advise you on which hardware or software you could best use. We can test your content or your software on our systems, and so forth and so on. Well, basically you could see the FAE department as one of those lower rows of cups on which the rest of AOPEN is built. Well, I might have exaggerated a little bit there, but you get the image, right? What you see here is our latest OPS player. It's the WB5100. It is built around a 35 watts TDP Haswell CPU. Actually, it's a very versatile system. It can not only drive a second screen, because it has VGA and HDMI output, but it doesn't really need an OPS slot, because on the back of the system there's also a power plug available. Well, using an OPS player has a couple of advantages. As you slide it into a monitor, you will always have space to mount it. And there's no need for an external power adapter, as the screen itself provides the power to the system. The OPS slot also takes care of the video signal, RS-232, USB, and so forth and so on. So a lot of the cabling is no longer needed. Just a piece of advice from me: if you ever install or have to swap one of those systems, please make sure that the monitor is disconnected from power before you do anything, otherwise you risk the chance of blowing up the hardware. These are all the specifications of this system. I'll just highlight a couple. It's 4K resolution capable. Well, it's built on a Haswell CPU, actually a Haswell refresh. It's actually a desktop CPU, but it uses only 35 watts. Well, the CPU, that is. There's a mini card slot available. It's a half-size mini card slot. There is a 2.5-inch hard drive inside. There are a couple of additional features like watchdog timer and some other features I will come back to. Well, what you see here is the front of the unit with all the connections. I'll just go from left to right and name them all. On the left hand side you have the power switch, and next to that there's a reset switch. Then you've got VGA out, HDMI out. There's the power LED and an ACPI LED. Then we've got two USB 3 ports. We've got the network interface and two audio ports, which are a microphone in and audio out. And then just above those two ports you have, there are now really holes, but if you ever receive a new system they will be covered, and those are actually punch-out holes. Well, on the back of the system, I don't have a picture of that, there's the OPS slot and the power plug, which is a normal power plug which we also use on our digital engines. Well, let's have a look inside the system. Well, the first thing you see when you open up the system, which you basically never have to do, but this is just educational, you see on the right hand side the 2.5-inch hard drive, which is 7mm high, and on the left hand side you see our proprietary cooling solution, the heatsink with a 65mm fan. And if you go even deeper into the system, you would see first the CPU. Then we have the memory slots. There are 2 slots. In this case, only 1 memory module, but you can enter 2 modules. Then we've got the half-size mini card slot, which you can use for Wi-Fi, for instance. Then we've got the OPS slot. And that was it. Just to summarize this system, you may have noticed that it is slightly larger than a normal OPS player. Well, this is done per design. By extending the housing just a little bit, we can ensure that our thermal solution will always get fresh outside air, meaning not from the monitor. And it doesn't even matter what the design of the monitor will allow you to, it will always get sort of fresh air. To make this thermal solution even more efficient, we've positioned all major components on one side of the PCB. So everything is cooled as efficient as possible. Well, just like our digital engine series, it includes features like real-time clock, wake-on real-time clock, automatic power after recovery, which means that if the power fails and it comes back on, the system will start up automatically, and of course our watchdog timer. Well, this OPS player has been tested in several different commercial OPS monitors, supporting both 4K and Full HD resolutions. Every test we threw at it, it passed without any problems. Well, then we have our engine cores. Our engine cores could actually be very useful accessories to our digital engines. They provide they can provide housing to a number of digital engines to make them rackable, stackable, provide cable management, and so forth and so on. The one you see here is the Engine Core 200, the EC200. The name already sort of gives it away. This housing can house up to 2 digital engines and their adapters. When mounting this in a server rack, because it's 19-inch, so it can be fitted in a 19-inch server rack, it will take up to 1.5 U of space. This is the Engine Core 700, EC700. As you can see, it can house up to 7 digital engines and their power adapters. The power adapters are internally daisy chained to one another, so you only need one power cord to connect this engine core. It's got 3 cooling fans, all 3 are 12 centimeters. The front comes with a key lock and a replaceable dust filter. The handles on the front are removable, so you can use it in a rack or you can use it standalone. When you use it in a rack, it will take up 4 U of space. And this is the Engine Core 650. It's the latest addition to this product line, and most likely also the most elaborate one. This can house up to 6 digital engines, but we also developed a RAID bay for this engine core. Due to its modular setup, it will allow for multiple different setups. So the picture shows you 4 digital engines and a RAID bay. You could also exchange the 2 digital engines for an extra RAID bay. The power in the system can come from different sources. Well, this slide looks a little bit crowded because yeah, well, the number of possibilities with this engine core are incredible. Power-wise, there are now two options. On the left, you will see the redundant power, DC redundant power, that's using all the normal power adapters. And on the right-hand side, you see the AC redundant power. That comes with a power board. And this power board will feed all the digital engines and the accessories. So it will also feed the rate base, for instance. At the moment, that's the only two options, but more are being developed. Well, as you can see, there are much more innovations available on this engine core. Like the mounting solution of the digital engines. They now have a sort of a swappable structure. What you see on the slide, there are two little lips, and then you can pull it out. Well, it's slightly different. This was an engineering sample. It has become slightly different. They're now secured with two thumb screws. If you loosen those, you can pull out the digital engine. The sides of the engine core have universal and adjustable mounting screws. It's for mounting with virtually any rack rail. To complement the versatility of these engine cores, we also have developed a couple of other accessories, like our KVM module, which you see on the left-hand side. Well, this can switch between 4 systems. It switches both VGA and USB. Well, the housing of this KVM is equal to that of our digital engines, so it can be easily integrated into any engine core. It can be powered separately, or it can be powered by our RDM module, which you see on the right-hand side. RDM stands for Remote Device Management. This device makes sort of a power pool. You connect all adapters of the digital engines into this device, and then it creates a power pool. If one of the adapters ever fails, the redundancy of the other adapters will provide power for the failed unit. It also it will also give you feedback if one of the adapters fails. So the system administrator will receive a notification that something has gone wrong in the system. The RDM can also drive the ventilators of the engine cores, so it will adapt to the airflow of the devices, and then again warn the system administrator when something is wrong with the cooling system. Well, I've run through it very quickly, and to close it up, I would like to mention that all of our digital engines, as well as the WB5100, can be provided with a Windows embedded image, which is tailored for our hardware, and if you want, also to your own wishes. Due to close cooperation with our software partners, we can ensure that our images are really built to last, and they will give maximum performance for the specific software. Well, generally speaking, Windows Embedded has a smaller footprint compared to the retail installations, because of a lot of the unnecessary data is left out of the installation. Embedded images can be built as secure as you want them to be, so they can also be very well suitable for server deployments, for instance. At the moment, we are mainly focused on Windows Embedded Standard 7 and on Windows Embedded Post-Ready 7, as these are still mostly desired in our market. So as such, we have for almost all of our x86 systems a vanilla Post-Ready 7 image available, already tweaked with most commonly used settings as a basis for your digital signage solution. Of course, eventually we will also migrate to Windows Embedded 8 standard, as the demand will pick up. Well, that's already the end of my webinar. If you have any questions, please let us know.